Okay, so today I'm going to show you just a little bit more about dividing polynomials in case you need a refresher. We're going to divide f of x by g of x. So the first thing we're going to do is figure out how to set up our box. And remember, the first term, you look at the degree of the first term to figure out how many columns you need. The degree of f of x is 4, so I know I'm going to need 4 columns in my box. To find out how many rows I need, we look at the second function, g of x, and the number of terms tells me how many rows I need. So g of x is a binomial. There are 2 terms, so I know I need 2 rows in my box. G of x is going to go on the outside, because that's what I'm dividing by. And then I'm going to start filling in the parts of the division problem that I know. So I know 6x to the 4th is always going to go in the first box. And if the first box is 6x to the 4th, and I've got 3x over here on the left, that means I'd have to have 2x cubed to make the multiplication problem work out. And if 2x cubed goes on the top, 2x cubed times negative 2 is negative 4x cubed. And when I go back up here and look to f of x, I don't want negative 4x cubed, I want negative 7x cubed. So the next box has to be filled in with negative 3x cubed. In order to get negative 3x cubed in that box, this term would need to be negative x squared, because negative x squared times 3x is negative 3x cubed. If I multiply then to see what goes in the bottom box, negative x squared times negative 2 is going to be positive 2x squared. Once again, I look up at f of x. This time I'm aiming to have 11x squared, but I only have 2. So I need 9x squared to make 11 total. And that's going to make this term 3x, because 3x times 3x is 9x squared. And if that's 3x, 3x times negative 2 is negative 6x. When I go back and look at f of x, I didn't want negative 6x, I wanted negative 9, so I need to subtract 3 more, which is going to make the last term negative 1. And then negative 1 times negative 2 is positive 2. That checks out with what I wanted for f of x. So my solution would be this part right up here. Okay, I'm going to show you one more problem, and this one is aimed at showing you what you do when there's a remainder for your division problem. So first I have my dividend, 5x squared minus 4x plus 12, and I'm dividing that by x plus 3. So again, I'm going to look at the dividend, this first one, to figure out how many columns to set up. The degree of this polynomial is 2, so I know I'm going to need 2 columns. I look at the divisor, or the second polynomial, to see how many rows I need. This one has 2 terms, it's a binomial, so I know I need 2 rows. So I'm going to end up with a 2 by 2 square. My divisor always goes on the outside here. And I'm going to start filling in what I know. So I know I have 5x squared in the very first box. If the first box is 5x squared, I would need 5x up here on the top, and that's going to make 15x when I multiply 5x times 3 on the bottom. If I go back to my dividend here, I didn't want 15x, I wanted negative 4x. So I'm going to need to subtract 19x in order for these two added together to give me negative 4x. If that's negative 19x, I need negative 19 up here. And when I multiply negative 19 times 3, we get negative 57. Unfortunately, I was aiming for positive 12 instead of negative 57, so my box didn't wind up taking care of the problem completely. I'm going to come down here and draw another box for the remainder in the problem. And again, I'm just adding something to negative 57 to give me positive 12. So negative 57 plus positive 69 is going to give me a positive 12. So my remainder, I can think of that as 69. Now, the way that I write my final answer to make this complete is I need the part of the quotient, 5x minus 19, that I already have, and I'm going to add the remainder on to the end. But it's not just the plain number, it's got to be 69 over x plus 3, so that if I were to multiply the quotient, so this whole thing, by x plus 3, I would wind up getting 5x squared minus 4x plus 12.